Welcome to this lesson on probability counting principles part 1. Let's have a look at example 1. How many 3-digit numbers can be made from this list 1, 2, 3, 4, 5 if repetition is allowed? So we have 3 positions to fill, okay? And each position can have 5 numbers to choose from, 1, 2, 3, 4, 5. So if we have repetition being allowed, that means we can repeat digits. So there are 5 options for the first digit, another 5 again for the second, and another 5 for the third. So there are 5 to the power 3, which is 125 different 3-digit numbers with repetition. What if repetition is not allowed? Well, again, you have 3 positions to fill. But now the first position can have 5 numbers to choose from. The second position will then have 4 numbers, as we cannot repeat the first digit that we chose. And lastly, the third position will have 3 digits to choose from, because we've chosen 2 already out of the 5, and we can't choose those again. So by the fundamental counting principle, there are 5 times 4 times 3, which is 60 different 3-digit numbers. So can you see that this number is much smaller than 125? So whether you have repetition or no repetition, that matters, because repetition allows you a larger number of possibilities, whereas repetition now lowers that number of possibilities that you can choose from. What if the first digit must be odd and the digits cannot be repeated? So again, you're choosing from this set here, 1, 2, 3, 4, 5. So again, we have 3 positions to fill. The first position can only have 3 numbers to choose from, because we want the first digit to be odd. So you can choose either 1, 3, or 5. Now the second position, that'll have 4 numbers. Because why? We cannot repeat the first digit that was chosen, and there were 3 possible digits for the first one. So we've chosen one of those. Okay, we've chosen one of them. All right, so that means the other 2 are still up for grabs, along with the other 2 that were remaining, in this case the numbers 2 and 4. So that means that the second position will have 4 numbers. Lastly, the third position will have 3 digits, because now we've chosen 2 digits already and we cannot have repetition. So how many ways are there? By the fundamental counting principle, there are 3 objects to choose for the first position, 1, 3, or 5. Then there are 4 objects to choose from the second position, so the remaining 2 numbers from the first set, 1, 3, 5, and then the other 2 numbers. And then once you've chosen that number, there are only 3 numbers left. So there are 3 times 4 times 3, which is 36 different 3-digit numbers. So that's even smaller than the 60 numbers we had previously. And why? That's because we've added an additional restriction that the first number must be odd. So can you see that every time you keep adding more and more restrictions or criteria on the way you can choose objects, the smaller and smaller the number of possibilities that you will expect to occur. So lastly, what if the first and last numbers must sum to 6, so add up to 6, and the digits cannot be repeated? So again, now we have an even stronger condition. Now the first number and the last number have a criteria, instead of just the first number, like in this example. So we have 3 positions to fill. Okay, the only combination of the digits 1, 2, 3, 4, 5 that will sum to 6 is either 1 plus 5 or 2 plus 4. Those are the only possible numbers out of those lists that will add to the number 6. We can't say 3 plus 3. Why? Well, we said digits cannot be repeated, so that's why we can't use 3 plus 3. Okay, so again, you just got to read the question very carefully, because these are very logical word problems. So we've got to make sure that we satisfy all the correct criteria. So what are the different options? Well, I know that 1 and 5 is one possibility. So I could have the first number as 1 and the last number as 5, or I could reverse it. I could have the first number as 5 and the last number is 1. Because when I add those 2, the first and last digits, then I get 6. And then the remaining numbers that can be in the middle here are 2, 3, and 4. So this is one possible way of having it, and this is one possible way of having it. So that's why we have 2 different ways that we can choose. Okay, and then that just means that there are 3 objects left to choose from. That's where we can get 2 times 3 times 1. Okay, the other way of thinking about it is that there are two options for the first digits, 1 or 5. Okay, so you're choosing 2 of those 5 of the possible 1, 2, 3, 4, 5. There are only 2 digits you can choose from in the first position. Then there are 3 objects in the middle that can go on, because we need the last number to satisfy the first plus last number is 6. So there are only 3 possible numbers. So that's where the second position comes from. And then the last position means that this number here, is only one number. There's only one number that'll satisfy that number plus the first number is 6. So there are 2 times 3 times 1 objects. So there are a total of 6 objects for that choice. We can use that exact same logic and apply it to this one here, where in the first case, it could be a 2 or 4, okay? So there are 2 different options that you pick for the first number. Bearing in that mind, once you've picked one of these, it can't be repeated. So that means the last digit has to be one of those 2. Okay, either the 2 or the 4. And then in the middle, there can be 3 of the remaining 5 numbers to choose from. So that same logic gives us 2 times 3 times 1 is 6. And then 6 plus 6 is 12. So that's even smaller than the 36. So this just means that if you have more specific criteria to choose from, so more restrictions, the smaller number of objects will likely to be occurring here in this case. Because the more restrictions we put on, the more specific the number has to be. So there can only be a few of them in the total number of objects that we can choose from. Okay, and we saw in the order here that 125, no restrictions, every digit can be repeated. In that 60, what was that? That was repetition not allowed. In 36, this was repetition not allowed, and the first digit must be odd. And then this 12 here was the first and last numbers must add up to 6, and the digits cannot be repeated. Okay, so this is the counting principles example 1. I'll see you in the next one.